Today we're going to learn about expanding and condensing logarithms, and this is really tied to our properties of exponents that we learned a long time ago. When you have something like x squared times x to the third, you add those exponents and it becomes x to the fifth. If we see multiplication inside of a logarithm, it splits up into the log of one of them plus the log of the other one. So just like in properties of exponents, multiplication indicates that we are going to be adding. So if you see multiplication inside of a log, we're going to split this up. This is called expanding because we're expanding it and making more logs. We're expanding it into two separate logs. Both of them are base b. The u goes in the first one, the v goes in the second one, and you attach them with addition. So if we're dividing inside the log, that becomes subtraction between the logs. And then this power property is really the most powerful property that logarithms have because it allows us to get rid of these exponents. These exponents move in front. So instead of the log base b of u to the n, it's going to become n times the log base b of u. Okay, so expand. And I will show you kind of the long way, the step-by-step way, and then I will show you how I kind of just get it done more quickly, like the shortcut way. So the long way would be, all right, I see that there's division here. I'm always going to deal with division first. So we've got log base 2 of 7x to the third minus log base 2 of y. Then I see that there's multiplication between the 7 and the x to the third. So we have log base 2 of 7 plus log base 2 of x to the third. We still have minus log base 2 of y. Then we're going to use this power property. This exponent on top is going to move in front, and that one will become 3 times the log base 2 of x. We've got log base 2 of 7 plus and minus log base 2 of y. So my shortcut is I notice that there are 3 things inside this log. So I'm going to go ahead and write 3 separate logs. I'm going to do this in pink. I'm going to write log base 2 of the first thing, log base 2 of the second thing, log base 2 of the third thing. Okay, so that's my first thing, my second thing, and my third thing. Okay, so 7 and the x to the third were on the top. Those were multiplication, so there's going to be plus in between them. And this log base 2 of 7 is also addition because it was on the top, but you don't need to start with plus, you just assume that the first one is positive. Okay, the y was on the bottom, so that log needs to be negative. And then the only thing that you have to do is move this 3 in front, and that would give you this answer. So that's kind of the shortcut way to do this. Let's try number 2 using the shortcut. So using my shortcut, you've got 25, you've got x to the 6th, and you've got y. So we are going to write out 3 separate logarithms and then decide what to put in between them. So I've got log base 5 of 25, log base 5 of x to the 6th, and log base 5 of y. These are all on the top. There is no bottom, so all of these logs are going to be positive. Now we have to deal with exponents. This green one is going to be 6 times the log base 5 of x. There's no exponents in this blue one. Now some of you might notice that 25 is really 5 squared. So it's going to be 2 times the log base 5 of 5. So if I kind of go in here and take that 25 and change that 25 to 5 squared, then you're moving that 2 in front, and it's 2 times the log base 5 of 5 plus 6 times the log base 5 of x plus log base 5 of y. There is one other property that you need to write down, and that's that if you have the log base b of b, it's going to equal 1. If your base and the number inside the log are exactly the same, it's going to cancel out. And why? Because if you were to change forms, this is b to the first equals b. b, anything to the first power is simply itself. So anytime you see log where the base and the number inside the log are the same, that thing is simply going to equal 1. So this is 2 plus 6 times the log base 5 of x plus log base 5 of y. Now, that particular property, like that sneaky step, I would not do that to you on a test or a quiz, but it might sneak up in your assignment. So if you're working on your assignment and you're thinking, I'm sure I have this right, what is not right? Why, when I check my answer, is this not right? Check to see if you have a log base something of that same thing. Okay, let's try the shortcut with number 3. The parentheses are really just there to contain everything inside that log. So you've got the log of 9, got the log of y, you've got 1,000, and you've got x to the second. There are 4 things inside this log. So we're got to squeeze this in here. I'll just zoom this in so we have more room. We have log of 9, log of y, log of 1,000, and log of x squared. Okay, the 9 and the y are on the top. So the first one needs to be positive. It always is, so you don't even need to put that in there. The y is on top, so that log is positive. The 1,000 is on the bottom, so that log is negative. The x squared is on the bottom, so that log is negative. If the thing is on the top, you put plus in between the logs. If the thing is on the bottom, you put minus in front of that log. Okay, now we have to deal with anything in here, any exponents. So this last one is going to be 2 times the log of x. Again, they're doing this thing with the 1,000. And the tricky thing about this is that you have to recognize that 1,000, oh my gosh, I'm erasing everything. 1,000 is the same as 10 to the third. So this is the log of 10 to the third. So this is minus 3 times the log of 10. And if you really want to get particular, 9 is the same as 3 squared. So this is 2 times the log of 3. Okay. Do you see how there's no base here? Anytime there's no base, it's base 10. So right here we have log base 10 of 10. That's going to cancel itself out. So we have 2 times the log of 3 plus the log of y minus 3 minus 2 times the log of x. Now, if I gave you this one on a test or a quiz, I would accept log of 9 plus log of y minus the log of 1,000 minus 2 times the log of x. So I would accept this answer on a test or a quiz, but your book is going to count this one as the correct answer. So just keep that in mind, that sometimes there's a few extra steps, and I'll give you a couple extra examples to look at. Okay, now we're going to basically do the backwards. We're going to condense. So my first step is always going to be to look at the number in front of the logs. There's a 2 in front of this log. That was originally an exponent. Once you've dealt with all the exponents that are in the front, now you can condense this down to 1 log. Now notice this is base 10, so you don't need to write the base. But I see that there's addition and subtraction, so I know there's going to be a top and a bottom. The 6 is in a positive log, so it goes on top. The 2 squared is in a positive log, so it goes on top. The 3 is in a negative log, so it goes on the bottom. And on a test, I would give you like letters and numbers combined. I would take this as your answer. Here, they're going to want you to actually plug this into your calculator. So 2 squared is 4. 4 times 6 is 24. And then 24 divided by 3 is 8. So this ends up being the log of 8. Let's look at one that's a little bit more realistic with like actual numbers and letters. First, put your exponents back where they go. So this is log base 3 of 7 squared minus log base 3 of x to the 5th. I see a negative, so I know that when I condense this down to 1 log, there will be a top and a bottom. The 7 squared comes from a positive log, so 7 squared is going to go on top. The x to the 5th comes from a negative log, so x to the 5th is going to go on the bottom. And I mean, you could do that 7 squared to get 49 over x to the 5th. Okay, I want you to pause the video and try number 6 on your own. Just give it a shot, be brave. And I just added a number 7. So on number 6, I want you to try on your own to condense that log. And then I want you to try to expand this log that I just wrote out for number 7. Give both of these a try, be brave, and then play the video to check your work. Pause it, pause it, pause it, pause it. Okay. So first thing I'm going to deal with is the exponents that are in front. So this is log base 8 of x squared, log base 8 of 5, and log base 8 of y to the 3rd. Okay. I know that I'm going to have a bottom because I see negative logs. X squared comes from a positive log, so x squared is going to be on the top. 5 comes from a negative log, so 5 is going to be on the bottom. Y to the 3rd comes from a negative log, so y to the 3rd is going to be on the bottom. Okay, number 7. I have 1, 2, 3, 4 things. Yes, that z is going to be its own thing. 3z is not one thing, it's 3 times z. So we're going to have 4 logs that we're going to have to connect. Okay, so I've got log base 2 of x squared, log base 2 of y to the 3rd, I've got log base 2 of 3, and log base 2 of z. X squared was on the top, so that one's positive. Y to the 3rd was on the top, so that log's positive. 3 was on the bottom, that log is negative. Z was on the bottom, that log was negative. Then deal with your exponents. All of these exponents need to come in front. So this is 2 times the log base 2 of x plus 3 times the log base 2 of y minus the log base 2 of 3 minus the log base 2 of z. Your assignment today is going to be in Big Ideas Math. So log in. Remember, you have to log in through Clever. Then click on the Big Ideas Math tile. Then you click on Assignments. Current assignments are in the tab that you see. If you have gotten behind on assignments, remember that there is an Overdue tab where assignments may be hiding that you haven't remembered to submit. And remember, to submit Big Ideas Math assignments, you have to click on your name, then submit. They don't just automatically submit at the end of the assignment. You have to click on your name and click submit. All right, if you have any questions, email me, post on Teams, and I will have help sessions in the next couple days. Hope to see you there.